Hi. In this video, we are going to look at more examples of so-called encounter problem, where in the problem, two people meet in somewhere. Okay, so let's look at this example. Here, let me again draw the graph to explain what the problem is about. You have two persons, A and B, living apart, and they walk towards each other at the same time. So A starts to walk towards B, and B starts to walk towards A. And they meet at a place 2,000 feet away from A. And then after that, they keep walking. So A will keep walk until he reaches the B's place and then turns back. And similarly, B will keep walking until he reaches A's place and then turns back. And the second time they meet is at a place that's 1,200 feet away from B's place. 1,200. Okay? And the question is, what's the distance between A and B? So typically for encounter problem, you use the fact that the distance equals speed multiplied by time. But for this question, we're given a couple distances. We're given that the first time they meet at 2,000 and second time they meet 1,200 feet away. But we have no information about speed or time. So how do you work on problem as such? So it turns out these type of questions are not about speed times time equals distance. This is really a question about ratios. Ratios and proportions. So what do I mean? Okay, let's look at the situation. So the first time they meet, A, B meet. Let's say the total distance traveled by A and B, this actually we know. So for the moment, let's ignore the fact that they meet 2,000 feet away from A. What's the total distance traveled? Well, first time A travels up to the point 2,000 feet, and B travels up to this point also 2,000 feet away from A. Okay, so the total distance, they just cover exactly the distance from A and B. This is the distance between A and B. All right. And also we know the first time they meet, distance for A we know. Because they meet at 2,000 feet away from A, so we know the distance for A is 2,000 feet. Meanwhile, the second time they meet, let's see what's the total distance traveled. So how much did A cover? Well, second time they meet, A will need to cover the whole distance from A to B plus the 1,200 feet. B will need to cover the whole distance from A to B plus this amount, again, I don't know. But the amount that I don't know plus the 1,200 feet, that together will again be the distance from A to B. So if you look at the graph, we have one distance from A to B, another distance from A to B, and the third distance from A to B. So total they cover 3 times the distance of AB. Okay, so now in terms of A, the total distance for A in this case, A would cover the whole distance from A to B plus 1200 feet. Distance AB plus 1200. Okay, because A and B are assumed to walk with constant speed, so the first time they meet, they cover just one distance of AB. The second time they meet, they cover 3 times the distance of AB. So which means the distance they covered will be 3 times. The ratio is 3 for A and B. And which also means the time they spend from the first time they meet. If the first time they meet, the time is, let's say, T. And then the second time they meet will be 3 times as much, 3 times T at the time. Okay, so in the middle, for example, if they spend 10 minutes to meet the first time, then they will spend 20 more minutes, and after 30 minutes they will meet for the second time. So how much distance will A travel? Well, A would have traveled 3 times as much distance. So instead of 2,000 feet, the second time meet, the distance A travel will be 6,000. So now what we know is that distance AB plus 1200 by this ratio, the relationship in terms of ratio will be 3 times the 2,000 A traveled, will be 6,000. And that immediately gave us the answer will be, what's the distance between A and B? Well, even though we don't know the speed, we still can figure it out, because this is 6,000 minus 1,200, because here's the relationship. That A traveled the whole distance plus 1,200, which turns out to be 6,000, equals 4,800. Okay. So what's the point of this problem? The point is that the time they meet first and the time they meet a second time, these 2 times are proportional. The second time they meet, the amount of time it takes will be twice than the first time they meet. So in terms of total, will be 3 times as much. So if the first time they meet in 5 minutes, then the second time they will spend 10 minutes more. They will meet at 15-minute mark. If the first time they meet at 10 minutes, the second time they will meet at 30-minute mark. But we don't care exact time when they meet. All we care is this ratio. The ratio is 3, so the distance traveled for A is 3. And so the first time we know A traveled for 2,000 feet. So we know at the second time they meet, A has traveled 6,000 feet. And with this information, that A traveled for 6,000 feet, we can figure out the distance between A and B. All right, so this is a problem solved with ratios and proportions instead of using speed multiplied by time. So now let's look at another example where we use ratios. So here the situation is you have 2 cars, again A and B. And they travel towards each other. And car A is faster. So when they meet, they don't meet at midpoint. They meet somewhere closer to B. So if the midpoint is this point, and the place they meet, there's a distance here, 50. Okay. And again, we're not given the speed of A and B. And the question is, what's the distance between A and B? Okay. So we're going to use ratios. Because we don't know speed, so we cannot use the distance equals speed multiplied by time. So how do we use ratios? Okay, let's just give a name for this distance B traveled. Let's call it just the B traveled, let's call the distance of B, dB, okay? Distance for B. And then what we know is that A is twice as fast. So when they meet, they travel for the same amount of time. So which means the distance for A will be double that, twice of the distance of B. Okay, so which means the total distance between A and B will be the sum of the two. This is dB, this is twice of dB, so it will be 3 dB. 1 plus 2 equals 3. And which means the midpoint, so in the picture, the midpoint will be 1.5 dB away from B and 1.5 away from A. So this is this part to the midpoint is 1.5 dB, and this part is dB. So now what is the 50? The 50 is the distance between 1.5 dB and dB. So it's 0.5 dB. Half of the dB is 50 miles. So now we know the distance B traveled is twice that much. Twice of 50 is 100 miles. And we figure out A traveled double of that. A traveled for 200 miles, and the total distance between A and B covered is 300 miles. Distance between A and B. So this is another example where the problem is solved using the ratios and proportions. Okay, next we're going to look at another example. This problem is going to take a while to state. So here you have A and B working towards each other. So this time we know the distance 200 feet apart. A works, B works, but what you're interested is in the dog, D. Yeah. The dog is A's dog, and he's excited to see B, so he runs towards B, and he meets B somewhere in the middle. And then he realizes that his owner A has yet to reach B, so he's excited. He will go back and chase and go to A and meets A somewhere in the middle. A keep walking, of course, and B will keep walking. So the next time the dog will turn back and meet B again, and somewhere closer to A, and sees B, then runs back to A. So the dog is going to zigzag and keep running. Okay, until they meet in the middle. B and A meet in the middle. Okay, then the dog is happy and it will stay. So the question is, how far did the dog run? Alright, so dog has been zigzagging, and this problem, all the speed, you know how fast dog runs, and you know the distance between A and B. So in theory, we could just use the formula, but it's kind of complicated because the dog actually runs quite a few segments, and it will be quite difficult to figure out the length of each segment. All right? So how do we solve this problem? And you can pause to think before I give the answer. This is a standard trick. So the solution to this problem turns out to be very easy. What we said for encounter problem, the basic is the distance equals speed multiplied by time. And it turns out does not matter the fact that the dog runs zigzagging. This formula still holds. So we know the dog's speed which is 600. All we need to figure out is for how long did the dog run? Now that's a much easier question. We don't need to worry about this zigzagging anymore. For how long does the dog run? Well, just take the amount for A to B to meet. So how long for them to meet? We know that they cover 2,000 feet, I'm sorry, not 200. They cover 2,000 feet, and their combined speed is 160 plus 240. So the time needed is just, the question mark is just 2,000 divided by, so this is 160 plus 240 is 400. So what's the question mark? Question mark is 2,000 divided by 400, which is 5. This is 5. So 5 minutes. That's how long the dog ran. And so the distance will just be 600 times 5 and 3,000 feet. So it's a surprisingly easy answer. Alright, this concludes our discussion on the encounter problems.